Go.
I'm Sean Michael. I'm a four-year student at Pennsylvania College of Technology in the Bachelor's for Electronics and Computer Engineering. So I have a couple of different projects set up. This one is a LED light organ, an 8-channel light organ. It's essentially 8 Sound key bandpass filters put in parallel. So what I do is I have music coming out of my laptop that comes through wires, comes into the light organ, and the light organ filters out the different frequencies coming in, and depending on the amplitude of the specific frequency, the LEDs light up to a certain value.
Right. Now, how many channels is this? Just one channel?
There's actually eight different channels
in
here.
From the music signal, the left-right channel, like stereo, is it, or just mono?
This is stereo, so left and right.
So you actually, okay, so
yep,
you process
both. I sum them together through
that
set of resistors.
Oh, I see. So it's a combination of everything.
Yep.
Awesome. Right, and what's the next, this is your senior project, right?
Yep, this guy is my senior project. Yep, it's an ongoing project. So I have a touchscreen, a separate microprocessor, and a third microchip here. This is going to be an electronic dashboard for a car. So essentially I plug it in through the OBD2 sensor through this port, and it communicates with this chip, the HCS12, and this touchscreen. When it's done, I'm going to be able to hit a button on the screen, say for speed. It's going to talk to the HCS12, which is going to tell this chip what to send the car. The car's going to get the values, and then it's going to send it back as fast as it can, and it's all going to come back and display the speed on the screen.
I see. Now, how will this work with any car or just certain
This will work
models?
with any car that has OBD2 in it, which is just about every car 1996 and newer.
Okay. Now, besides speed, what else can you get from the car?
RPMs. I have a mass airflow, specific temperatures, and
things like oil pressure and
stuff
things like that. Just everything, plus any error codes that might occur.
Yes,
okay. Awesome.
That would be a possibility.
Yeah. Right. Now, what manufacturers is the display from?
The touchscreen is from a company called 4D Systems.
Okay.
They're an Australian company. It's a resistive touchscreen. It has its own 16-bit microprocessor in here. The programming language is a mixture of C, BASIC, and I believe Pascal. They call it 4DGL, and it essentially is to control the screen, and has a couple of outputs like serial, CAN, and stuff like that.
Okay, awesome. Okay, great. And then you have a third project. This is a Arduino board, right?
This is the NetDuino Plus.
NetDuino Plus.
Yes, there's a 32-bit microprocessor on here. It also has internet capabilities to this Ethernet port. I currently have it set up to a router, which is set up to the internet. Right now, I'm just running one of the basic programs that allows me to go online and switch on and off an LED. So, and for my laptop, I'm not connected to the internet except for through wireless.
Through the wireless.
So, essentially, through the web page, how I understand it is all this code that's on this screen is run through JavaScript right off of the NetDuino board. That essentially, when I built the project and start running the project, it creates a connection to a relay server out in the internet, which I communicate through specific codes and identifiers, and the relay out in the internet essentially acts as my personal IP address, so that instead of I don't have to register this guy with its own IP. So I can go onto any device, and as long as I have any kind of internet capability, I can go to this website and I can switch on and off the LED.
Awesome. So this would be an example where you could have like a home automation. You could turn your things on and off at your house, your different, like your furnace or your AC. So you could control
any kind of
remotely.
actuator.
Yeah. Awesome. Cool.
So,
All right. Thank you.
You're welcome.